Yes, let's wait for 1 minute. Yes. Very good evening to Physics Cartoon Camera. Welcome to this channel. Physics Cartoon Camera is giving daily live sessions from class 9th standard CBSE, further 10th standard, 11th standard and 12th standard. So every day the series will be starts from 10 p.m. to 11 p.m. Most of Indian students, they are very free at 10 to 11 and they want to analyze the basic concepts of physics from class 10th standard to 12th standard. Further, it reaches to NEET examinations, IIT JEE foundation courses. So these are all under the streamline what I'm promising to the country children. Now coming to the part, yesterday there is a wonderful session on class 9th standard CBSE physics chapter motion. So there are the rural India students, they have participated and I received a number of emails. So there is a doubt session and each and every subtopic I'm asking a few questions. If you can clear the doubts, yes, very fine, I'm there to help you. As well, in my description I have given my email ID. You can send any doubts related to physics. So today is the second day. We can continue from yesterday session. Yes. Yesterday we have discussed what is motion, straight line motion, uniform motion, non-uniform motion. Then we have studied distance and displacement. Yes. What is the difference between distance and displacement we have studied. Now today, what is speed? You see the wonderful students, they want to win the competition. So they are running very fast. So how to decide who is first? Everyone looks like first. They are under the competition. Yes. So in this conjunction, so what is the speed? What is the speed of a person? We need to identify. Yes. The speed in the sense of how much distance the student traveled in certain time. Okay. Distance covered by a body per unit time is called speed. So speed is equal to distance by time. Speed is equal to distance by time. So how much the total distance traveled by the student in a unit time. So the units are meters per second. Meters per second or kilometer per hour. We can say kilometer per hour also. Now the students are asking, sir, the speed is equal to average speed. We will see what is average speed. For example, the student started at point A, he reached to point B, and still further he reached to point C. Still further he reached to point D. So finally, the student started from point A to point D. That is his actual distance. So the distance covered in how much time, that we can call it as the speed of a person. But now average speed in the sense of between A and D there are the different points, that is B and C. In this between B and C, between A and B, what is the distance and how much time taken? And between B and C, what is the distance and how much time taken? At the same time, distance C and D, what is the distance and time taken? So individual distances and individual time intervals. So that is called as average speed. Average speed we can call it as total distance by total time. Alright, so this is average speed. So another way, average speed is nothing but speed. But sometimes in casually in the classroom, if I ask a student, from house to school you are reaching, what is your speed? So little they'll be confused. Sir, maybe I came by scooty. My father dropped me approximately 40 to 50. Then question will be start. Is it 40 to 50 continuously from house to school? No, sir. Sometimes might be 0. If signal comes 0. At starting position 0. And the school gate entrance very little, like 5 kilometers per hour, something like that. So that different speeds, sir. But overall that is 40 by 50, something like that. That speed is instantaneous speed. Okay. So instantaneous speed in the sense of at a particular place, at a particular time, the speed of a vehicle we can call it as instantaneous speed. Instantaneous. Instantaneous speed, we can say that a particular position or a particular time, in a particular time, the speed of a vehicle is called as instantaneous speed. Okay. Now speed is equal to distance by time. Speed is equal to distance by time. Distance is equal to speed into time. At the same time, time is equal to speed by distance. Speed by distance. Now speed is equal to distance by time. Distance is equal to speed into time. Time is equal to speed by distance. So we can able to alternate the formulas. Next, what is velocity? Is speed and velocity are the same? We will see. In a speedometer, we are seeing that different values, and the down some more values, and there is a bar kind of label here, the down. The meter reading will be changed continuously. Okay, so this kind of thing. Now this is odometer, and this is speedometer, what we can call it as. Okay. Now velocity. How to define velocity? Velocity in the sense of displacement by time. Velocity is equal to displacement by time. Now you can say a student from house to school, yesterday we discussed the actual path traveled by an object called as a distance, the minimum distance traveled by an object called as a displacement. Now the distance by time we mentioned as a speed, displacement by time we are mentioning as a velocity. So velocity is equal to displacement by time. Very simple, displacement by time. Now what is average velocity? Let's say an object at point A started with initial velocity u, it reached to point B, final velocity v. Now when we can say that is average velocity? Final velocity minus initial velocity by 2. final velocity minus initial velocity by 2, that is average velocity. So average velocity units again meters per second or kilometer per hour. Okay. Now, shall we proceed the next? We will see. Velocity is equal to displacement by time. Displacement is equal to velocity into time. Time is equal to displacement by velocity. So we can able to alternate the formula. Now, instantaneous velocity. What is instantaneous velocity? When a body is moving with a variable velocity, the velocity of a body at any instant is called instantaneous velocity. Repeating again, when a body is moving with variable velocity, the velocity of a body at any instant is called instantaneous velocity. Now, instantaneous speed we said. When we are driving a car or riding a vehicle, which place, which point or which time, the speed of a vehicle we can call it as a instantaneous speed, what we discussed. At the same way, instantaneous velocity. Now the difference between speed and velocity, what it is? Speed. The speed is the same rate of change of distance of a body. Velocity. Velocity is the time rate of change of displacement of a body. Okay. Speed tells nothing about the direction of a motion. Velocity tells the direction of motion of a body. Speed is a scalar quantity because which is having only magnitude but no direction. Velocity is a vector quantity. There is a direction. Speed of a body can be positive or 0. Velocity of a body can be positive, 0 or negative. So average speed of a moving body can never be 0. But average velocity of a moving body can be 0. Alright. Next one is acceleration. What is acceleration? What is acceleration? Whenever we are riding a scooty, the first work what we will do, we will accelerate the vehicle. Acceleration in the sense of little more speed up. I am accelerated because I am speed up. I accelerated because I am slowing down. Again, that's also acceleration. Honeybee, keep on changing the direction. That's the reason we are observing a buzz sound. Okay? There is a buzz sound we are observing. So this is acceleration. Now what is acceleration? Acceleration is equal to rate of change of velocity, which means acceleration A is equal to final velocity minus initial velocity by time. A is equal to V minus U by T. We can say rate of change of velocity. Rate of change of velocity, that is acceleration. Okay, the units of acceleration, how we can able to find out. Let's say A is equal to velocity by time. What is velocity? Velocity units are meters per second, we can write. So time units, seconds. So overall how much? Meters per second by second, which means meters per second square is the units of acceleration. Clear? Next. Any doubts the children can ask me? Yes, very happy evening, Virendra. And you can ask me any doubts, you can chat. Yes, I can reply. I'm there to work for the children. Now, rate of change of velocity, we studied now. Acceleration. Acceleration is taken as a positive when it is acting along the direction of velocity. And it is taken to be negative when it is acting against the direction of velocity. Okay? Acceleration also can be negative. Acceleration is a vector quantity. Why? Because acceleration is equal to velocity by time, as we discussed. acceleration is equal to velocity by time. So velocity is a vector quantity because velocity is equal to displacement by time. Displacement is a vector, hence velocity is a vector. Once velocity is a vector, acceleration also the vector. Clear? Now acceleration of body is constant, it is said to be go through uniform acceleration. Uniform acceleration when it comes when an object freely falls down, that is uniform acceleration. Clear? Next. Let's see till now what children's understood. The first question. An object travels 16 meters in 4 seconds and then other 16 meters in 2 seconds. So what is the average speed of an object? Option A 3.33 meters per second. Option B 4.33 meters per second. Option C 5.33 meters per second. Option D 6.33 meters per second. So how to solve this answer? Generally the students will ask me the question, sir, how to solve the numericals in physics? This is one of a most important tough task. How to solve this? Students, again you read the question and frame it. What is the given data? What is the given data in the question? In this question they have asked an object travels 16 meters in 4 seconds. Okay, they have given distance. They have given distance, right? So distance how much? 16 meters. In how much time? 4 seconds. Very good. Then next another 16 meters. Another 16 meters. How many seconds? 2 seconds. Now average speed. Average speed is equal to total distance by total time. So total distance how much? 16 plus 16 by 4 plus 2, which is 32 by 6. So approximately it comes as 5.33 meters per second. Very good. Excellent, Virendra. You chose option C. Option C is the right answer. Yes, we will check. Yes, exactly. 5.33 meters per second. Next question. Usha swims in a 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to other end and back along with the same straight path. Find the average speed and average velocity of Usha. Repeating. Usha swims in a 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to other and back along with the same path. Find the average speed and the average velocity. Here there is a lightly error. It's not average velocity. Let's say acceleration. What is their acceleration? Of course velocity also the same part, but acceleration is right question over here because options they are given in meters per second square as acceleration units. Now what is given data? Always find out what is given data. Usha swims in a swimming pool that is 90 meters. Here the distance of the swimming pool is 90 meters. She covered 180 meters in 1 minute. Time t is equal to 1 minute. 1 minute immediately you convert into seconds, which is 60 seconds. Okay. Now the distance covered 90 plus 90 180. Yes, to and fro she swimmed. Now what they're asking? Average speed. Average speed is equal to total distance. Total distance how much? 90 plus 90, which is 180 by time how much? 60. Yes, 180 by 60. How much? Which is 3 meters per second. Next, what is acceleration? Let's say Usha from point A to point B, that is 90 meters, she swim and she came back again. Once she came back, displacement value will be 0. Once displacement 0, velocity 0. Once velocity 0, acceleration also 0. So what is the right option? Option A, s is equal to 3 meters per second, a is equal to 0 meters per second square. Option B, s is equal to 2 meters per second and a is equal to 5 meters per second square. Option C, s is equal to 2 meters per second and a is equal to 0 meters per second square. And option D, s is equal to 0 meters per second and a is equal to 3 meters per second square. The right answer is A. Fine. So total average speed is 3 meters per second and acceleration will be 0. Clear? Yes, we shall proceed. Now, wow, what a big question. Students might be get scared about the long lengthy question. No need to worry. We can answer in a very simplest way. Now, the question here, starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applied brakes such that the velocity of a bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle, both the cases. It looked like very big question. Yes, but answer is very simple to solve. Always I'll recommend what is given data. What is given data? Starting from a stationary position. Once an object starting from stationary position, initial velocity u is equal to 0. Yes. Rahul pedals his bicycle to attain the velocity of 6 meters per second. So that is the final velocity, 6 meters per second in 30 seconds. So t is equal to 30 seconds. Clear? Then he applied the brakes. Once he applied the brakes, what happened? The velocity will comes down. Now from where to where? This 6 meters per second is the next part of initial velocity. Yes. Rahul pedals his bicycle going very more speed. Again he applied the brakes. At the time of applying the brakes, his speed is 6 meters per second. So that is the initial velocity. After applying up the brakes, what is his velocity? Velocity will be 4 meters per second. Okay. In how many minutes? How many seconds now they given? 5 seconds. So t is equal to 5 seconds. This is given data. So what is required data? Calculate acceleration. Acceleration both the cases. Acceleration in both the cases. Very good. So here A is equal to in this case v minus u by t. V minus u by t, rate of change of velocity. So A is equal to 6 minus 0 by 30, which means 6 by 30. 6 by 30 in the sense of 1 by 5, which means 0.2. Okay, 0.2. 0.2 meters per second square. This is the first case. Second case, how much? Again, A is equal to V value 4 meters per second minus U by T. So 4 minus 6, how much? Minus 2. Minus 2 by 5, which is 0.4 meters per second square. So this is the way we can able to solve it easily. Okay. Option A. A1 is equal to 0.4 meters per second square. A2 is equal to minus 0.2 meters per second square. Option B, A1 is equal to 0.2 meters per second square and A2 is equal to minus 0.4 meters per second square. Okay. Option C, A1 is equal to minus 0.2 meters per second square, A2 is equal to minus 0.4 meters per second square. Option D, A1 is equal to 0.3 meters per second square, A2 is equal to 0.4 meters per second square. So as per our numerical, what is the best option? Yes, online children, what is the best option? You can able to choose it. Yes. Next question. Under what conditions is the magnitude of average velocity of an object is equal to average speed? Under what conditions is the magnitude of average velocity of an object equals to average speed? Now, once distance is equal to displacement, speed is equal to velocity. So once average speed is equal to average velocity. Under linear motion, when the displacement is equal to distance, average velocity is equal to average speed, which is in a straight line motion. Next question. What does the odometer of an automobile measures? Option A, acceleration. Option B, velocity. Option C, distance. Option D, order. In automobiles, odometer can calculate the distance. I showed you in the picture. Next, when will you say a body is in uniform acceleration and non-uniform acceleration? When you will say a body is in uniform acceleration and non-uniform acceleration? We will see that. When the change in the velocity per unit time is constant, it undergoes uniform acceleration. When the change in velocity per unit time varies with time, it undergoes non-uniform acceleration. Hope it's clear. Next question. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 hours. Find the acceleration of the bus. Repeating the question again. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 hours. Find the acceleration of the bus. Option A, 4 km per hour. Option B, minus 4 km per hour. Option C, 8 km per hour. And option D, minus 8 km per hour. Yes. So, any doubts over here? How to calculate the acceleration? As you know that, given data they have given, initial velocity u is equal to 80 km per hour. Okay. Final velocity v is equal to 60 km per hour. In time t, 5 hours. So, acceleration A is equal to v minus u by t. What is final velocity? 60 km per hour. Minus, what is initial velocity? 80 km per hour. By time, 5 hours. Very simple. So 60 minus 80, how much? 60 minus 80, minus 20 km per hour by 5, which is minus 4 km per hour. Hour square actually it comes because per hours. Hope it's clear. Hope it's clear. So this is the way rate of change of velocity, final velocity minus initial velocity by time. Alright. Next. Yes. Right answer is minus 4 kilometers per hour square. Next question. A train starting from a railway station and moving with a uniform acceleration attains a speed attains a speed 40 km per hour in 10 minutes. Find its acceleration. Repeating. A train starting from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. So how to solve this? Again the same. What is uniform acceleration? Uniform acceleration and speed 40 km per hour. They have given speed is equal to 40 km per hour. So now the time they have given in 10 minutes. 10 minutes we have to convert into hours because acceleration units and options they have given in hours. So 10 minutes how many hours? 1 minute. 1 minute. See 1 hour 60 minutes. So 1 minute 1 by 60 hours. 10 minutes 10 by 60 hours. So with this calculation into 1 by 60 hours, which means 1 by 6 hours. Now find its acceleration. Acceleration is equal to velocity by time or speed by time or whatever. 40 km per hour by 1 by 6 hours. So which means 40 into 6 which is 240 km per hour square. So option A 200 km per hour square, option B 45 km per hour square, option C 240 km per hour square, option D 96 km per hour square. So what is the right answer? 240 km per hour square, which is option C is correct option. Yes. Probably the numerical solvations of physics is easy to the children. Still any doubts? Please ask me. I'm there to answer your questions. Yes. Now we can see the next proceedings of this topic. We are so enthusiasm in learning. At the same time, we can start with the same spirit. What is the next subchapters? Till now what we have studied? We have studied about what is motion, what is straight line motion, and how that rest and motion are relative terms. Then we have studied about distance and displacement. Then speed is equal to distance by time, velocity is equal to displacement by time, acceleration is equal to rate of change of velocity. So these concepts we have studied. Can we represent motion graphically? Is it possible? Why can't? It's possible. Let's say you can see this. There are the two cars, blue car and red car. Carefully you can observe the blue car, each 10 kilometers, equal distances in equal intervals of time which is traveling. Red car, each 20 kilometers, sometimes it's traveling. If an object travels, equal distances in equal intervals of time is called uniform motion. So once you can see that there is a distance time graph. On y-axis, we have mentioned distance. On x-axis, time. You can see equal intervals of time in equal intervals of distances. We can call it as uniform motion. Non-uniform motion. You can see that a car, if it is a red light, stopped. If it is green light, going very fast. Yellow light, little slow. So different time intervals, different distances. If an object travels, that is non-uniform motion. If an object travels unequal distances in unequal intervals of time is called non-uniform motion. Yes, children, any doubts? You can ask me through chat. And Physics Cartoon Camera is providing you the science facts, live sessions, recording classes, and as per the CBSE board, a sessional reasoning and case-based questions. Before the examinations, there is a some of important question and answers can be explained through live. My intention to start this to help to the children enter the country, so they no need to pay the tuition fees, and the burden must be less to the parents. At the same time, the children can able to understand very easily, quickly. So whatever the support, yes, I'm there. Now, velocity time graph. Most of the children asked me, sir, what is uniform velocity? How to identify the uniform velocity? You can see in this picture. Time is increasing. Of course, this vehicle is moving. Time is increasing. At the same time, the velocity of a person will be the same. The velocity of a person will be the same. That is uniform velocity. Uniform acceleration, non-uniform acceleration, we can see that what it is. What is uniform acceleration and what is non-uniform acceleration? You can see this picture. A ball is moving from down to top. Whenever it is moving down to top, slowly the speed is decreasing. The speed is decreasing, which means velocity is decreasing. Top diagram, you can see the ball from top to down which is moving. So the speed is increasing. Yes. So equal time intervals, equal velocity, that is uniform acceleration. Next, what is deceleration or retardation, we can call it as. You can see in this picture, the lorry applied the brakes, which is quite left side, which is moving. So its kind of speed is reducing. At a certain speed, after if speed reduces, that is deceleration. You can see this dog. It came very fast and applied the brakes. It skids. That is deceleration. And while running race, you can see that the car, which is heavy speed and suddenly brakes applied, slowly the decreasing the speed. That is retardation. Deceleration, we can call it as. Next, let me see what you have understand. Let me see what you have understand. Shall I proceed further? Yes. Are you ready? Are you ready? Are you ready? Yes, we can go ahead. First question. First question. What is the nature of distance time graph for uniform and non-uniform motion of an object? Option A, non-straight line, straight line. Option B, straight line, straight line. Option C, straight line, non-straight line. Option D, positive curve, non-straight line. The right answer you can see now here. Straight line and non-straight line. Distance time graph of a uniform motion will give you the straight line. Non-uniform motion will give you non-straight line, which is curved line. Okay. Next question. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? Option A, uniform velocity. Option B, uniform speed. Option C, uniform acceleration. Option D, body is at rest. Right answer is body at rest. Because distance time graph, if you consider, time increases but the distance position will be the same if the object at rest. So that is body at rest is the right answer. Next question. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? Speed time graph parallel to time axis. Option A, uniform velocity. Option B, uniform speed. Option C, uniform acceleration. Option D, body at rest. The right answer is uniform speed. Okay. Next, what is the quantity which is measured by the area occupied below the velocity time graph? Option A, velocity. Option B, speed. Option C, acceleration. Option D, displacement. The right answer is displacement, because velocity time graph, velocity is equal to displacement by time. So once we can consider velocity time graph, the displacement will be carry forward. We can able to identify. So once we can recap it, distance time graph is a uniform motion. If it is the curved line, non-uniform motion. Velocity time graph, uniform velocity, and uniform acceleration. This we have studied. Any doubts? Any doubts, the children? Any doubts you can ask me. Till now the graphs, numericals. If you have any doubts, feel free to ask me any questions related to motion chapter. If you're not subscribed, subscribe my channel. And every day 10 to 11 p.m. most of the rural India students, they have messaged me, they emailed me. I'll give that complete value to all the students. And at 10 to 11 p.m. every day the live sessions, Monday to Saturday. So you can join and you can ask me the questions of CBSE class 9th standard. Then after 9th standard classes, I have started with class 10th standard. Then simultaneously class 11th and 12th. And there are some hands-on experiments. I'll show you how physics works. Coming to question papers, yes, CBSE model papers, at the same time CBSE board papers, we can discuss in a live session. And huge gathering I'm expecting. And subscribe the channel, and I'm there to help you. I committed to the students. Any questions you can ask me. Hope it's clear. Yes. So every day 10 to 11 p.m. we'll meet again. In the description have email ID. You can ask any questions. I'm there to answer your questions. At the same time, who not subscribe the channel, and it has to reach to the village rural India students. Tomorrow, again the same time, we will continue the session of equations of motion. I'll explain you in the easiest way. After, there are very important questions of CBSE, how they will ask you from motion chapter. Thank you so much. Have a great day. Jai Hind.